Everyone, this is Professor Oaks, and in this video we are going to talk about multiplying and dividing rational expressions. So let me write that down here. Multiplying and dividing rational expressions. Alright, so what are we going to do here? Well, we're going to do this similarly to how we would multiply and divide just fractions, or just just a over b times c over d. That's a times c over b times d, and then we will simplify the result. Or for a over b divided by c over d, we'll multiply the a over b by the reciprocal of c over d, so that's d over c, and so that will give us a d over b c, and then we'll simplify the result. All right, so let's just go ahead and move forward in that fashion here. So here we go. So the first one is 5c over 6d times 4d over 20c. So let me focus that for us here. All right, so here we go. So before I go ahead and do this, I'll just go ahead and rewrite it exactly using the rules here. So 5c times 4d divided by 6d times 20c. Now, I could go ahead and just multiply 5c times 4d and get 20cd, and then 6d times 20c to get 120, and then I can write it cd, so these are in alphabetical order if I would like. Alright, and then I can find the GCF of the numerator and the denominator. 20 cd and 120 cd will be 20 cd, so then I divide by 20 cd and by 20 cd, and then I'm left with, well, 20 cd divided by 20 cd is 1, and 120 cd divided by 20 cd is going to be 6, so this is 1/6. Or, again, I know that you've seen this before, but I want to be clear on this, right? If instead of rewriting this as 20 cd over 120 cd, you could go ahead and have 5c times, and then factor 4d into 2 times 2 times d, and then 6d into 2 times 3 times d, and then 20 into 2 times 2 times 5 times c. Alright, and then cancel out the common factors in the numerator and denominator, or divide out the common factor. So 5 over 5 is 1, 2 over 2 is 1, c over c 1, d over d 1, 2 over 2 1. So I have, well, 1 over 3 times 2, which is 1 over 6. So I get the same result, but then I didn't have to multiply the numbers together and get really large numbers. So it's up to you whichever way you would like to do this. All right, let's try again. So we have 3 over 1 minus 6x times 6x minus 1 over 3x plus 2. All right, so let's go ahead and figure this out here. So we have a 3 times 6x minus 1 over a 1 minus 6x times 3x plus 2. Now, the one thing that I notice here is that I'll highlight it for you. This 1 minus 6x and 6x minus 1 are very similar, but they're not the same, so I can't divide them out just like this, but I can think to myself that, well, 6x minus 1 is actually equal to -1 plus 6x. And now I'm even closer to looking exactly like 1 minus 6x, but instead of a positive 1, I have a -1. Instead of a -6, I have a +6, right? So I can actually factor out a -1 and make this 1 minus 6x. So -1 times 1 minus 6x, all right? Now, if I do that, I have 3 times -1 times 1 minus 6x divided by 1 minus 6x times 3x plus 2. And now I can see that I can divide out the greatest common factor, which is 1 minus 6x. So I have 3 times -1 is -3, and that is all over 3x plus 2. Now, again, I cannot divide out the 3's here because that's not a greatest common factor. All right, because the greatest common factor would be meaning that this term over here in the denominator also had a factor of 3, but it doesn't. It actually has just a 2 over here. All right, so the answer here is -3 over 3x plus 2. Let's try another one. So we have multiply and simplify here. We have u minus 2v over 3u times 6u squared minus 6uv all over, or that's all over u minus 2v. All right, so we see right away that if you're very savvy here, you can see that we just go ahead and proceed like normally. So multiply here and multiply here. But if you notice right away, the u minus 2v's could divide out. So I'm left with 6u squared minus 6uv all over 3u. And then I can do one of two things here, actually, right? One of the things I could do is actually find out that the numerator has a greatest common factor of 6u and write it as 6u times u minus v, and then that will be all over 3u. And then now I see that 6 over 3 is 2, so I have 2, and then the u's divide out, so u's divide out, so u over u of 1, and then I have a u minus v left here, so u minus v, but that's not one of the answers. But if I distribute the 2, I have 2u minus 2v. Now, here is another way that you could have looked at this. You could have actually said, well, this is 6u squared minus 6uv over 3u. Well, that would be 6u squared over 3u minus 6uv over 3u. And then you can simplify here and have 2u minus 2v. All right, so that's another way you could do this. I will tell you right now, one thing that I want you to be clear on that is absolutely wrong, all right, but I want to tell you because it's a common mistake that people make. All right, this is absolutely wrong. If it was 3u over 6u squared minus 6uv, you could not do this. 3u over 6u squared, all right, minus 3u over 6uv. That's no. All right, this is no, do not do that. You can only do this sort of thing here if the subtraction is in the numerator. All right, and that's because that's the rule for fractions, right? Because it is a over b, where is it? Yeah, minus, all right, c over b, when these both have the same denominator, you can write it as a minus c over b. So try to remember that there's no rule for, say, common numerators, right? No rule for common numerators, only for common denominators. So think about it like that, and hopefully you aren't one of the people who try to make a mistake like that, because it's wrong, wrong, wrong. All right, so you don't want to be that person. If I see you on the street and I know that you made that mistake, I will point it out that you were that person who made that mistake I talked about in this video. It's nothing to be ashamed about, it's just wrong. All right, so now we have 5a to the third over 6b squared c squared divided by 10a cubed, or to the third power, all over 3b squared c to the fourth power. So remember, when I divide, I'm going to multiply by the reciprocal of this divisor here. So I have 5a to the third over 6b squared c squared times 3b squared c to the fourth over 10a to the third. Now again, there's lots of ways that you could do this, but I'm just going to multiply straight across and then simplify. So 5a to the third times 3b squared c to the fourth is 5 times 3 is 15, so 15a to the third b squared c to the fourth. And then 6 times 10 is 60. Then I have a to the third right here, then b squared, and then c squared. So then I see that the a to the thirds divide out, and I see that the b to the seconds divide out, and then I see with what's left that there is a GCF of 15c to the second. So I'll divide that out just like this. So I have 15 divided by 15 is 1, and then c to the fourth divided by c squared is c squared, and then 60 divided by 15 is 4, and c squared divided by c squared is 1. So I'm left with just 1 times c squared, and 4 times 1, or just c squared over 4. What a time to be alive. Alright, so I hope that you're enjoying this video on multiplying and dividing rational expressions so far. Here's another one. Let's go ahead and multiply and simplify the expression below. So we have x squared minus 25 times 10x over x squared minus 5x times x plus 5. So what I'll start by doing is just factoring all of the expressions. So x squared minus 25, I can write that as a difference of squares. So remember, this is what the formula for factoring a difference of squares looks like. So x squared minus 25 is x squared minus 5 squared. So that's x plus 5, x minus 5. So we have x plus 5, x minus 5, and then for the x squared minus 5x, we can factor out the GCF of x, so x times x minus 5, and then we have a 10x and a x plus 5 right here. So now I can go ahead and cancel out the common factors, or divide out the common factors in the numerator and denominator. So x plus 5 divided by x plus 5 is 1. X minus 5 divided by x minus 5 is 1. X divided by x is 1. So I'm left with 10 over 1, or just 10. What a time to be alive, right? So let's try another one here. So we have a squared plus b squared over c squared minus d squared divided by, that means, remember, we'll have to use the reciprocal here, a squared plus b squared over c minus d. So the a squared plus b squared, that is a sum of two perfect squares, so that is prime, or just cannot be factored, at least for our purposes here. So now we know that c squared minus d squared that's going to be c plus d, c minus d, the difference of two squares. So let's go ahead and rewrite this as a squared plus b squared over c plus d, c minus d, and then multiply by the reciprocal, so c minus d over a squared plus b squared. And now we'll divide out the common factors in the numerator and denominator. So a squared plus b squared divides out, c minus d divides out. So that means there's 1 left in the numerator, and then we have c plus d in the denominator. So 1 over c plus d. What a time to be alive. All right, let's try another one right now. So here we go. So we have x squared plus 3x minus 10 over x squared minus 3x times x over x minus 2. So let's go ahead and try to factor the numerators and the denominators here. So x squared plus 3x minus 10, that will be x plus 5, x minus 2. Then for the denominator, x squared minus 3x, I'll factor out an x. So x times x minus 3. Then I have times x over x minus 2. I will divide out the common factors in the numerator and denominator. That will be x minus 2 and x. So I'm left with a grand total of x plus 5 right here over x minus 3. And there is my answer. What a time to be alive. All right, so I hope that you're enjoying this. So here is another example. This one, again, you will need to go ahead and factor the numerator and the denominator, but this is division, so I'll start by multiplying by the reciprocal. So I have x squared minus 4x plus 4 all over 3x squared minus 3x minus 6 times x plus 2 over 2x squared minus 8. All right, so there's definitely a lot of factoring to be done here. So I'll start by factoring the x squared minus 4x plus 4 because that will be the easiest part. That's x minus 2 times x minus 2. Now, for the 3x squared minus 3x minus 6, I'm going to start by factoring out a greatest common factor of 3. So 3 times x squared minus x minus 2, and then x plus 2 over the 2x squared minus 8, I'm going to factor out a greatest common factor of 2. So it's 2 times x squared minus 4. And now I'm going to continue factoring here in the denominator, factoring this x squared minus x minus 2 and this x squared minus 4. So I have x minus 2 times x minus 2. And then I can factor this x squared minus x minus 2 into x minus 2 and then x plus 1, and then I can factor the x squared minus 4 into x plus 2, x minus 2, and then I go ahead and divide out my common factors in the numerator and denominator. So I have x minus 2 over x minus 2 is 1. X minus 2 over x minus 2 is 1. X plus 2 over x plus 2 is 1. So in the numerator, I'm left with 1, and the denominator 3 times x plus 1 times 2, and 3 times 2 is 6, so I have 1 over 6 times x plus 1. So there is my answer right there. What a time to be alive. All right, so let's try another one. Here we have multiply and simplify. So we have 6z squared, and let's factor the denominator into z minus 2, z plus 1. Then we have z minus 2, and then we can factor a factor of 3 out of the 3z plus 9 to get 3 times z plus 3. And then I can divide out the common factor of z minus 2, and then I know 6 divided by 3 is 2, so if that's 2, then I really have in the numerator 2z squared over, and in the denominator, z plus 1 times z plus 3. What a time to be alive. There's my answer right there. All right, let's try another wonderful example here. Let's divide and simplify here. So again, this is division. So we need to multiply by the reciprocal. So I have 3c plus 3d over 6c squared minus 6d squared times 2c minus 2d over 6c plus 6d. And then I just go ahead and factor out all of the greatest common factors that I can. So in the numerator here, I have a 3 times c plus d. The denominator, 6 times c squared minus d squared. The numerator over here, 2 times c minus d. The denominator here, 6 times c plus d. Now I see that I have a difference of two perfect squares here that can be factored even further. So I have 3 times c plus d over 6 times c plus d, c minus d. Then 2 times c minus d over 6 times c plus d. Then go ahead and divide out all of the common factors that you can. So we have c plus d over c plus d, 1, c minus d over c minus d, 1. And then you can go ahead and just multiply 3 times 2, 6. Then we have 6 times 6 is 36. And c plus d, 6 over 36 is 1 over 6. So 1 over 6 c plus d. What a time to be alive. All right, so let's do just a few more here because I can tell that you're really enjoying this. So this one is a problem in which we are having dividing here. Whoops, I dropped my pen here. So we have dividing. So let's again multiply by the reciprocal. So we have 2 plus 3r over 10 minus 15 r times 6 minus 9r over 4 minus 9r squared. So I'll factor out all of the greatest common factors here. So 2 plus 3r over the denominator here is a greatest common factor of 5. So 5 times 2 minus 3r. Then the numerator here has a greatest common factor of 3, so 3 times 2 minus 3r. And then 4 minus 9r squared is a difference of two perfect squares. It's 2 squared minus 3r squared. So we have 2 plus 3r, 2 minus 3r. And then I go ahead and just divide out the common factors in the numerator and denominator. So 2 plus 3r and 2 minus 3r. So I have 3 over 5 times 2 minus 3r. What a time to be alive. All right, so let's try just a few more before we run out of time here. So here we have dividing. So let's divide here, but we'll do that. So we have z squared minus 2z minus 3 divided by z squared plus 3z plus 2 times, we'll multiply by the reciprocal, z squared minus 3z minus 10 over z squared minus 2z minus 15. Now we'll factor. So in the numerator we have z minus 3, z plus 1. The denominator, z plus 2, z plus 1. The numerator over here, z minus 5, z plus 2. The denominator over here, what do we have here? We have, oh, that's a 15. So that will be a z, right, minus 5, z plus 3. And then let's go ahead and we'll divide out the common factors here. So what do we have? Z plus 1 divides out. Z minus 5 divides out. Z plus 2 divides out. So we're left with z minus 3 over z plus 3. So z minus 3 over z plus 3. What a time to be alive. All right, so let's go ahead and move on to the next one. We have a dividing here again, so I'll go ahead and multiply by the reciprocal. So I have s minus t over s squared minus t squared times s squared minus 2st plus t squared over s squared plus 2st plus t squared. So let's factor here. So we have s minus t over s minus t, s plus t, then times, all right, let's factor this numerator here. So we have s minus t, s minus t, and factor the denominator, s plus t, s plus t. And now we will divide out the common factors. So we can divide out one of the s minus t's, and then that looks to be it here. So we have in the numerator s minus t to the second power left, and then the denominator s plus t to the third power. What a time to be alive. All right, so just a couple more examples here because I know that you're enjoying this just as much as I am. So let's try another one here. This is another division problem, so we need to multiply by the reciprocal. So I have a squared minus 2a minus 8 over a squared minus 5a plus 4 times a squared minus 2a plus 1 all over a squared plus 6a plus 8. Then I will go ahead and factor here. So I have a minus 4, a plus 2, over a minus 4, a minus 1 times a minus 1 times a minus 1 over a plus 4, a plus 2. And then I will go ahead and divide out the greatest common factors. So I have a plus 2, then a minus 4 divides out, a minus 1 divides out, and I'm left with a minus 1 over a plus 4. What a time to be alive. All right, so now it's time for our very last example of this video. So I hope that, as we come to an end, that you really just have savored every moment of this that you possibly could have. So this is another division problem here. So I will multiply by the reciprocal. So I have 3x plus 6 over x plus 3 times x squared plus x minus 6 over x squared minus 4. Then I will do the factoring. So if I factor a greatest common factor of 3 out of the numerator here, I have 3 times x plus 2, that's over x plus 3. Then I will factor x squared plus x minus 6 into x plus 3, x minus 2, and then x squared minus 4 is a difference of two perfect squares, so I have x plus 2, x minus 2. Now I divide out the common factors in the numerator and denominator. So that's x plus 2, x plus 3, x minus 2. So I'm left with 3 over 1, or just 3. What a time to be alive. I hope that you enjoyed this video on multiplying and dividing rational expressions, and I hope that you are already looking forward to the next one. Thank you and have a great day.